guys, welcome back to another episode of Math Lessons with brrly. So today we're gonna be learning about complex numbers, and it's 11:24 p.m. as you can see, but that doesn't matter, guys. It's literally fine. Oh wait, I need to screenshot this for the thumbnail. Anyway, so complex numbers are a concept in Algebra 2, I think, or trig. I think it's Algebra 2. But anyway, I'm in Algebra 2 right now, and it's kind of boring because it's the start of school and we're really only doing review. But right now we're also doing like different types of functions, like step function, piecewise function, that stuff. And yeah, but I can't wait for the day we get into complex numbers because it's really fun. So during summer school, I took geometry over the summer because I wanted to advance into Algebra 2. And since I would finish like my IXLs early because our teacher made us do a lot of IXLs, like a lot, since we were taking a math class over the summer and we had to like put a lot of information in our brains in the span of about 2 months. Yeah, and I would finish my IXLs early, so I would do like other IXLs that would introduce me to new math topics, and I did one about complex numbers and it was fun to learn about. So yay. This is chapter 2 of the book, The Art of Problem Solving, volume 1. And yeah, okay, so complex numbers are, it's I is the square root of -1. So you know how people like tell you that you can't find the square root of a negative number? Well, that's actually a lie. So if you wanted to find like the square root of -64, for example, you would have to break this down into it'd be like -1 times the square root of 64, because that's what it is. You'd have to factor out the negative, so that would be I times the square root of 64. And what's the square root of 64, you ask? It's 8. So 8 times I is 8i. So yeah, cool, right? Anyway, there's also like so complex numbers. This is not a complex number. Like, that's not what it's called. It's called I actually don't know what it's called. I think it's just I, right? Let me see. Yeah, it's just referred to as the square root of -1. And then this, which is a real number multiplied by I, it's called a pure imaginary number. Also, if you can hear my mom and her friend talking in the background, don't mind them. You probably don't even understand be it, cause yeah, like I barely understand it, but anyway, dude, Jesus, she's talking so loud. Okay, but anyway, anyway, let's do like I to the power of 2. So that would be the power of -1 times the square root. And you know when you multiply a square root by another square root, it equals the thing. Because we learned like we learned that, we learned that this raised to the power something is also the same as this, and that this times this is equal to 64. Because if you simplified it, it's 8 times 8. So, you know. And we learned that when you multiply numbers that have the radical and the same number under the hood, that it gets rid of the radical and whatever. Okay. So that means that I squared is equal to -1. So what would I third, I 4, and I 5 be? So I third would just be I squared times another I, which is equal to -1 times the square root of -1. Which is just -1 I think, right? What? I third is equal to I times I squared, because I times, so yeah, so just -I. -I. Oops. And this would be I squared times I squared, which is equal to -1 times -1, which is equal to 1. Then this is I squared times I, which is equal to -1 times -1 times I, which is equal to I. Because these would cancel out to be 1. And then, yeah. And then I6 would be I squared times I squared times I squared, which is just -1. And it goes in the cycle over and over again. So it goes from this. Let me write out the... And then it repeats the process. So -1, -I, 1, I. So now let's solve I to the power of 17. Okay. Well, since we know that 17 divided by 4 would give us 16 and 1 over 4, that means the process of this thingy repeats 4 times, because 16 divided by 4 is 4. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Then on the 17th one, it would be a -1. So that means I to the power of 17 is -1. And let's do another one. I to the power of 69. So we would just have to find the remainder of 69 divided by 4, which I kind of don't know. 62, 66, wait. 62 divided by 4, what? Wait. Wait, 13 times 4 is 4, 3, 12, okay. 13 times 4, 14 times 4. Huh? Wait, is 13 times... Oh shoot, oops. So it's... Am I stupid? Wait, 12, 13... Wait. Plus 12 is 40. Plus 12 is 3. Huh? Give me a moment. It's 11:34, guys. You can't blame me. 69 divided by 4. 17 times? What? Wait, but 40 and... 62 and 40 is just 4 times 10. And then you just put... Oh, 22. Oh, shoot. I thought it was plus 12. Let's not talk about that. So that means 17 times 4, 8, 2, 6. So that means 1 over, so that means it's also equal to -1, I think. Right? Yeah, okay, whatever. Now one last one to really give us some practice. I to the 1972. We need to find the remainder again. Personally, I'm not gonna calculate that. It's 493. So that means there's no remainder, meaning it's this one. So it's equal to I. Awesome, guys. Okay, we learned the basics of imaginary numbers and all that shenanigan stuff. Now we're gonna move on to actual complex numbers. So complex numbers are just like when a real number is added to an imaginary number. So like if you have like 3i plus 7, that's an imaginary number. Square root of 2 plus 3i. I think the real number goes before the imaginary one, I guess. Every real number is also a complex number. The imaginary component is just 0. Oh, so like what they're saying is this is still a complex number, but the imaginary component, so like the imaginary component right here, it would just be 0, I. So that means I isn't really there, but it's, those complex numbers which are not real are called imaginary. What? This is not exactly the same. Can you write a number which is imaginary but not pure imaginary? What's that mean? Let's clear up some confusing definitions. Yes, please. 3 is both real and complex but not imaginary. 3 is not real but is complex, imaginary, and pure imaginary. 3 plus 3, 1, I is neither real nor pure imaginary but is imaginary and complex. Okay. I don't really think you guys need to know the vocab. Maybe I'll do a part 2 because, complex numbers are weird. Complex variables are usually designated. Let's add 3, 1, 2. Okay, we'll go over complex number operations tomorrow, which is pretty much how to add, subtract, divide, and multiply complex numbers, because that's a lot of information that will probably take me a while, and I don't want to do that right now because I'm kind of sleepy, as you can tell by my voice. But yeah, complex numbers are really fun. You guys should do IXLs on them because, really fun. And yeah, let me do my awesome thing. Okay, thanks for watching, guys. No outro music because honestly, I don't care at this point. Oh, 77%. Did you guys know that 7's my favorite number? I bet you didn't. Okay, goodbye.